Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a trigonometric equation with complex numbers or with imaginary numbers. So we have tangent theta minus secant theta equals I being the square root of -1. I is also known as I squared equals -1. So real or complex, we're going to try to solve for theta. And you can think about if we can get I from real angles. So how do we solve an equation like this? Just like normal, let's go ahead and use some identities maybe, right? For example, tangent theta can be written as sine theta over cosine theta. So let's go ahead and write tangent as sine theta over cosine theta. And then secant is the reciprocal of cosine, so we can write it as 1 over cosine theta, and then the whole thing is equal to I. Great. Does this make sense? Let's find out. We have a common denominator, so we can write this as sine theta minus 1 divided by cosine theta is equal to I. And then if we cross multiply from here, we get sine theta minus 1 is equal to I cosine theta. Now, at this point, you can kind of think about either side. For example, the right-hand side being imaginary. Is that possible for that to equal sine theta minus 1? Of course, theta does not have to be a real number. And do you think it's going to be a real number in this case? Probably not, right? So it should be okay. When theta can be complex, sine theta can be anything, which is basically going to be a complex numbers. By the way, if you're new to complex numbers, go ahead and check out my lecture videos where I go over the basics of complex numbers. And if you like algebra, number theory, and trigonometry, maybe a tiny bit of geometry, go ahead and check out Cyber Math, Cyber with an S. Great, so we have this equation now, and what can we do to solve that equation? Now, our equation turns into something easier to handle because we only have sine and cosine, which is good. So one thing you can do with these kinds of equations is you can use the Pythagorean identity, right? Sine squared theta plus cosine squared theta equals 1, even when theta is complex. Yes, when theta is complex, sine and cosine don't have to be between -1 and 1 inclusive, but this identity still holds. But as is, I can't use it, right? So what I need to do is maybe square both sides, right? We can give it a try. At least that's going to give us some squares. So let's go ahead and set those equal to each other one more time and square both sides. If you square both sides, it's going to look like this. You have to be careful though. Like I said earlier, I squared is -1 because I is known as the square root of -1. There are two square root, or there are two numbers whose square equals -1, but only one of them is considered the principal square root. Okay? So if you square both sides here, left-hand side gives us sine squared theta plus 1 minus 2 sine theta. That's how I usually expand it. On the right-hand side, we have to be careful. I squared is -1, so this is going to give us negative cosine squared theta. Great. Now, we're going to go ahead and put the sine and cosine together so that we can use the identity, right? So add cosine squared to both sides, and you're going to end up with sine squared plus cosine squared, which is 1, right? And this is going to give us the following. Now, since this is 1, and we have another 1, like 1, 1, 1 plus 1 is going to be a 2. And at this point, you could probably just move the sine to the other side so that, and then kind of switching sides here automatically. 2 sine theta equals 2 gives us such a simple equation, right? Let's divide both sides by 2, and that gives us sine theta equals 1, which is awesome, don't you think? Great, so that's so simple, right? Now, where is sine equal to +1? Well, if you think about where sine would be 1 or -1 or 0, you can immediately think of the unit circle, right? And sine theta is going to be 1 when the y value on the unit circle, of course, that's going to be right here. So it tells us that, okay, this is supposed to be pi over 2, right? That point represents pi over 2 on the unit circle. So theta can be pi over 2, but we're allowed to add multiples of 2 pi. So we can safely say that, okay, if sine theta equals 1, then theta is pi over 2 plus 2 pi n, where n is an integer, positive or negative, right? Great. So we got a solution. Here's the thing. You need to check the solution with the original problem, because maybe it doesn't work in the general case, right? So our original equation was tangent theta minus secant theta equals I. Now this is particularly important because there are points, values, angles, whatever, at which tangent is undefined. Same thing goes for secant, because tangent and secant are both, fractions, and whose denominators can be 0, which shouldn't be 0. And if you think about it, for example, what happens if sine theta is equal to 1, right? So we have theta equals pi over 2. The problem is, at pi over 2, cosine theta is 0. And obviously this makes sense, right? When sine theta is 1, sine squared plus cosine squared equals 1, which means cosine theta is equal to 0. That automatically follows. When cosine is 0, Houston, we have a problem, because remember again, tangent is sine over cosine, and secant is 1 over cosine, and they're both problematic. Even if we had one of the problems, like let's say we had tangent minus cosecant, we would still have a problem, because you can't have partially undefined equation. So this means that our equation does not, or at least the only solution we found does not satisfy or makes the original equation undefined. What does that mean? That means we don't have a solution, okay? Unfortunately. So how could we approach this problem from a different angle? Let's go ahead and take a look. Tangent theta minus secant theta equals I. Now, one thing you can do is maybe go back to where we were, like sine theta minus 1, sine theta minus 1 is equal to I cosine theta. We got that from here, right? Obviously, we had to make sure cosine does not equal 0, but I didn't care because at the end we were going to check that anyways. But you should sometimes keep the domain in mind so you don't mess up with something like this, okay? So now I want to turn this into something in standard form. And if you know a little bit of complex numbers, and if you don't like, again, go ahead and check out the lecture videos. But we can write a complex number in standard form as a plus bi, or in the polar form as r times e to the I theta, where theta is the angle, r is the modulus, so on and so forth. Now, if you write it as a plus bi, how can we do that, right? Or what does this mean? If you know Euler's formula, e to the I theta is cosine theta plus I sine theta. So it's definitely a good thing to be able to write it in this form. And we can kind of do that by bringing this over to the left. So like sine theta minus I cosine theta is equal to 1. Great. We're not there yet. We don't have the cosine first, and we have a minus sign. But that's okay. We can do a couple things. We can find an angle, alpha, in terms of theta, of course, such that we should be able to write it like this. But the question is then, okay, what is that angle, right? What is alpha in this case? So we kind of need an alpha in terms of theta such that the name would change. So we have to use pi over 2 or 3 pi over 2 in the process. And we also want the following. We want the sine to be negative and cosine to be positive. Why? Because when cosine changes name, notice that it becomes positive, or it stays. And when sine changes the name to cosine, when we replace alpha with something, which you're going to see in a little bit, sine needs to be negative. So which quadrant is going to give us that? That's the fourth quadrant. Make sense? Okay. To get to the fourth quadrant, there's a couple things you can do. I think the best solution would be to use 3 pi over 2, because if you think about alpha being a acute angle, and if you add 3 pi over 2 to it, like when you add pi, it's going to be here, and when you add pi over 2, another pi over 2, So in other words, you're adding 3 pi over 2 to the alpha or theta, and that is basically going to give you this angle. So where the sine and cosine are switched, and sine is positive and cosine is negative, or the other way around. Okay? So in other words, this is what I'm trying to say. Alpha should be 3 pi over 2 plus alpha. Oops, I meant theta. So that when I evaluate this cosine 3 pi over 2 plus theta, this is going to give you a positive value because cosine is positive in the fourth quadrant. You have to look at the original function, right? And sine is going to be negative in the fourth quadrant. Great. So this will give us what we are looking for. And then, which means the angle we're looking for is this one. So alpha is 3 pi over 2 plus theta. But why is that important? Now, when you write it in this form, you can also write it as e to the power I times something, something, right? You can do that. But also, this means, because this equals 1, it just means that this is supposed to equal 1, and this is supposed to equal 0. And from here, you should be able to find the value of theta, but again, that value is going to be problematic because the smallest value you're going to find is pi over 2, because 2 pi, cosine 2 pi is 1, obviously. And then, but that's going to be problematic from a tangent and secant perspective. Okay, great. So basically, we end up with no solutions, and Wolfram Alpha is able to verify that as well. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and happy Thanksgiving, and bye-bye.